Heart disease is a leading cause of death globally. The most common form of heart disease is coronary heart disease, a condition affecting the blood vessels that supply the heart. In 2008, around 7.3 million people died from this condition. We are told that high cholesterol levels are a major risk factor for coronary heart disease.
Stop any person on the street, including children, and ask them what causes heart disease. They'll tell you. They know the word cholesterol. It's quite a complicated chemical word, and children already know it from a very young age.
We now seem to worry about cholesterol levels as much as heart disease itself, and a new disease known as hypercholesterolemia has emerged.
In the United States, it's part of a yearly ritual to get your cholesterol level managed, and you think that your cholesterol level is like your overall grade on your future health.
The focus on cholesterol has also led to a global cholesterol-lowering industry that generates billions of dollars each year for pharmaceutical companies and food manufacturers.
You just can't get away from high cholesterol.
More than 40 million people now take medications known as statins to lower their cholesterol levels.
Statins have become one of the most widely prescribed categories of drugs in medical history.
These are the #1 profit makers for the pharmaceutical industry. These are the darlings of the pharmaceutical industry. This is their babies.
However, a number of doctors and researchers have for decades been questioning the role cholesterol plays in heart disease.
People believe it to be true. They believe they've read it, they've read it, they've read it. It's not there. It's just non-existent.
And strong evidence exists to suggest that the benefits of statins have been exaggerated by pharmaceutical companies keen to increase their profits.
We are beginning to see now that a lot of the facts that we are given are actually somewhat manipulated.
Doctors are not trained in nutrition. They know no more than you do.
It's a very hierarchical world, medicine. International opinion leaders say it, the national opinion leaders agree. No one's going to stand up and go, well, I don't believe that.
This stands as organized crime, but there's a lot more money in this. And in fact, many, many more people get hurt.
Well, the idea that cholesterol saturated and or saturated fat causes heart disease, I mean, you can actually track this back to a chap called Virchow, who is still sort of renowned for certain other discoveries. He looked at people who died in accidents and in autopsies, looked at their arteries, found that they had thickenings in their arteries, had a look at them and decided that they were full of cholesterol. So up until 1917, no one even thought there was such a disease as heart disease, really. And it was only really after the Second World War when in America there appeared to be thousands and thousands of youngish, healthy men dropping dead of heart attacks that it really first became an important issue.
Since the last war, nutrition has become a science, according to Dr. Keyes.
Ansel Keys was a well-known physiologist. As an advisor to the US Department of Defense during World War II, he formulated meals for combat soldiers that became known as K-rations. Keys was also the lead investigator of the Minnesota starvation experiment, a human starvation experiment involving 36 conscientious objectors. In 2011, a report published by the Associated Press revealed a number of unethical medical experiments had been conducted in the past in the United States. One of these experiments involved injecting 11 volunteers with malaria, then starving them for 5 days. One of the authors of this study was Ansel Keys. Ansel Keys is also regarded as the father of the diet-heart hypothesis, the idea that dietary saturated fat raises cholesterol levels and causes heart disease.
So cholesterol at the time was a convenient villain. We had this problem of atherosclerosis, a hardening of the arteries, and there was a great deal of pressure, a need really, to blame it on something.
A chap called Ansel Keys came along and said, I know what causes heart disease. Heart disease is caused by eating. Well, initially he said eating cholesterol, but he found that if you ate cholesterol, it had no effect on cholesterol levels. He then said, well, it must be saturated fat.
He drew a graph in which he showed 6 countries, the amounts of fats in calorie terms along the x-axis and the numbers of heart disease deaths in those countries. And he drew what was probably the most perfect graph you can get. It was a superb line, marvellous. There's a flaw. because at the time that Keyes did this in 1953, there were data from 22 countries he could have used. He didn't use the 16 that didn't agree. And when you add those to his graph, there is no relationship at all. You find countries with much higher levels of heart disease eating less fat, and vice versa.
It was pure manipulating, or we could call it fraud. This is pure fraud.
Despite the obvious problems with this study, the work completed by Ancel Keys is still quoted today as evidence in support of the diet-heart hypothesis. Most authorities state that this straight-line relationship can also be seen between cholesterol levels and the risk of heart disease.
There is a clear, what's called a linear relationship, so it's a straight line between cholesterol levels and risk of heart disease, so there's no plateau. The lower your cholesterol levels in nature, the lower your rate of heart disease.
However, there are a number of contradictions to this idea that raised cholesterol levels increase the risk of heart disease.
Firstly, for example, the UK does not have a particularly high cholesterol level in comparison to most other European countries and possibly worldwide.
According to data published by the British Heart Foundation, average cholesterol levels for men in the UK are the 15th lowest on a scale of 45 European countries. Despite this, the UK has one of the highest rates of heart attacks. In addition, cholesterol lowering on a population level does not seem to help. Again, in the UK, the percentage of people with high cholesterol has reduced significantly since 1994. Some age groups now have almost 40% less people with high cholesterol. Yet the rate of heart disease has stayed the same. We have been led to believe that saturated fat and cholesterol simply clog up the arteries and cause a heart attack. But where did this idea come from? And does it have a scientific basis?
Certain foods are high in saturated fat.
There is an advertisement pushed out by the Food Standards Agency.
This is the average amount of saturated fat a person consumes in a month.
Where they show a woman taking what they say is saturated fat out of a fridge. She pours it down the sink and it blocks the sink waste pipe up. And then the advertisement says,
the saturated fat can clog this pipe. Imagine what it's doing to yours.
What they show in the adverts on television is as far from what actually happens as you can get, I should think.
You may have seen adverts where people had cigarettes and there was fat coming out the end of it.
We've all tried to give up smoking.
That's nonsense. It's utter nonsense. So how does fat, the non-existent fat from the cigarettes, end up in your arteries when you smoke? People have said that smoking increases the risk of heart disease. That's true. But when you smoke, other things happen.
What actually happens is not the inside of the artery getting blocked by anything. What happens is that the artery wall, called the endothelium, is broken in some way. And just like if you cut your finger, you get a scab form on top of it, which then falls off. A similar thing happens in the artery. You get the damage to the endothelium, repair mechanisms are all set into motion, all the building materials needed to repair that and form a scab are pushed there, which includes cholesterol, because that's a major building block for just about everything that goes on in the body. And then, because you can't afford to have a scab fall off in an artery, it would block it, the endothelium grows back over it, and it's subsumed into the artery wall. And that's what's called atherosclerosis. It's nothing inside the artery at all, it's actually inside the artery wall.
What you've got to look at is what's causing damage to the lining of the artery wall. Because once you've damaged the lining of the artery wall, in a very simplistic way, those clots become covered up, the repair process pulls them into the artery wall, but they then become a focus for further development of damage. And if you want to know what causes heart disease, you have to look at things that damage the artery wall, interfere with the disease process, and cause increased blood clotting. That's really what you're looking at here.
When we have a cholesterol test, the results are usually described in terms of good cholesterol and bad cholesterol. The good cholesterol is called HDL and the bad cholesterol is called LDL.
What HDL and LDL are carriers. These molecules are made up of fats, proteins, certain vitamins, and other structural factors, and within them the cholesterol sits. So to a degree, the HDL and the LDL are transport mechanisms or little lorries that carry the cholesterol to the parts of the body that need them. And we've been given the idea that the high density lipoprotein is good for us and the low density lipoprotein is bad for us. But we also know that a lot of other things are carried. CoQ10, which is a specialized enzyme required in many different processes, but predominantly needed in mitochondria, which are the little batteries that live inside cells and give the cell energy to function in the way that it should. A cardiac muscle, a heart muscle, can have 2,000 or 3,000 mitochondria, and without CoQ10, the process of turning oxygen and sugar into energy is not going to function at an optimum. Beta-carotene, the more functional form of vitamin A in the body. We also know that vitamin E is carried by the HDLs and LDLs. And this is a very important vitamin because it's a powerful antioxidant.
Cholesterol-lowering medications, in particular statins, are prescribed to lower bad cholesterol levels. However, a large study published in the American Heart Journal in 2009 found that the level of so-called bad cholesterol is actually lower in people with heart disease, not higher. This study included around 137,000 people who had been admitted to hospital with heart disease. It included patients from 541 hospitals in the United States. All of these people had their LDL level measured within 24 hours of admission. The researchers found that the average LDL level for this group of people was actually lower than the average level for the American general population. The average level for people with heart disease was 104, and the average for the general population was 123. If people with heart disease have lower levels of so-called bad cholesterol, why are some countries around the world spending billions of dollars each year lowering these levels?
I think it's fair to say that we can't look at HDL or LDL and say that one is good and one is bad.
In fact, the studies now show that drugs that increase HDL had to be stopped because they increased the rate of heart attacks.
Well, the theory is false, but it's gained so much momentum and it's become so lucrative that it's almost like a freight train going down a hill.
And in fact, I find it interesting that exactly at the same time that Virchow was talking about his idea of cholesterol causing heart disease, Rokitansky was proposing that these plaques are caused by blood clots on the surface of arteries. That was 1851. And he was right, Virchow was wrong. It just so happens Virchow's idea took over the world, if you like.
It does seem that most countries around the world are in agreement about saturated fat and cholesterol being a major cause of heart disease. One country in particular, where the diet heart hypothesis has been adopted, is Denmark, where the government have introduced a fat tax. This tax applies to foods, such as butter, that contain saturated fat. However, a short journey across the bridge to Sweden reveals a different attitude towards dietary fat.
In fact, there was a poll in Sweden recently. It showed that 20% of the Swedish population, they follow the low-carb, high-fat diet. And some places it's very difficult to get butter in the shops.
Dr. Uffe Ravnskov is an independent researcher based in Sweden. His articles and letters challenging the diet heart hypothesis have been published in the most respected medical journals in the world.
We have succeeded in introducing this type of diet to the diabetic patients, a low LCHF diet. This low-carb, high-fat diet has been very popular in Sweden. Thousands of diabetic patients have reported on the internet that as soon as they started with this diet, the low-carb, high-fat diet, they improved immediately. In a few weeks, their body weight went down, their blood sugar normalized, they could skip their diabetic medicine, it wasn't necessary any longer to use insulin, and other complaints disappeared from these patients.
Humankind existed on this planet for eons, and for eons we prized the fatty foods, the fatty cuts of meat, the cream on the milk, the butter, the eggs, and the oily fish. You need to have 2 eggs minimum per day. if you have a cold, or if you have an exam coming up, or if you're depressed, or if there is some other trouble with brain function, memory, you need to eat 4 or 5 eggs per day to avoid heart disease and cancer and other degenerative conditions, to prevent them and to even reverse them, to remove them from your life. Revert back to the natural foods that we humankind used to eat for millennia.
We frequently forget that cholesterol is essential for life and that a little higher cholesterol is associated with longevity, decreased malignancies, improved defense against infections. So when you lower cholesterol by any means, you can have adverse effects just from that.
Cholesterol is used in large quantities 24 hours a day for the whole of our lives in building and repairing cells. It's used to make hormones, it's used to make bile acids with which we digest fats, a whole range of things, including vitamin D.
So low cholesterol levels is going to muck around with your cell membranes, the ability of the cell membrane to allow things in and out. It's going to compromise the function of the nervous system, and it's going to stop the body from dealing with stress well. And I've only just touched upon a few of the issues because cholesterol can mirror many other molecules in the body and has very similar attributes to, say, vitamin D.
There's a Honolulu Heart Health study looking at elderly males living in Hawaii and Honolulu, and they found that the lower your cholesterol level was, the earlier you died. There's a major study in Austria which showed that the lower your cholesterol levels were at any age, the younger you died. And there's almost no contradiction to this. If you have low cholesterol levels, you are likely to die younger.
Another way to investigate the causes of heart disease might be to look at the differences between different socioeconomic groups. People with a low income have a much higher risk of dying of heart disease. For example, in England, men in the lowest socioeconomic group are almost 3 times more likely to die of heart disease than men in the highest socioeconomic group. We might expect, therefore, that there are more people with high cholesterol in the lowest socioeconomic group. However, the reverse is true. The lowest socioeconomic group have fewer people with high cholesterol. Women in England, in the lowest socioeconomic group, are 5 times more likely to die of heart disease than women in the highest socioeconomic group, but have approximately the same number of people with high cholesterol. All of the experts agree that heart disease is a complex condition with several contributing factors. However, this data raises questions about the importance of high cholesterol. One potential risk factor not often mentioned relates to social support. People in the lowest socioeconomic group are more than twice as likely to indicate a severe lack of social support, a factor which could, of course, increase psychological stress. To find out how psychological stress can affect the heart, we went to New York to see Dr. Paul Roche. Dr. Roche is president of the American Institute of Stress, clinical professor of medicine and psychiatry at New York Medical College, and honorary vice president of the International Stress Management Association. We began by asking Dr. Roche if he could define what stress actually is.
Well, no. Simply because nobody's been able to do that. The term was coined by Hans Selye around 1936, who defined it as a non-specific response of the body to any demand for change. It really wasn't very helpful. He redefined it as the rate of wear and tear on the body. Well, that's a pretty good definition of aging, which stress certainly contributes to. He used to answer the question this way later on. Everybody knows what stress is, but nobody really knows.
So stress itself is difficult to define. But how might psychological stress from a lack of social support translate into an increased risk of heart disease?
You think about all the advances made in diagnostics with MRIs, SQUID, PET scanning, positive emission tomography. These are all advances that have nothing to do with cholesterol or something in the blood. These are all advances that are based on energy medicine. And that is the medicine of the future, and certainly the future for stress research, in my opinion. Medicine is entering a new paradigm. Good health depends upon good communication between the constituency of an organism and with the external environment. The question is, how does communication take place in the body? Well, we know there are hardwired connections with the central nervous system, and we know that the endocrine system sends out little chemical messengers from the brain and hormones and so forth and so on. But we visualize communication in the body at a chemical molecular level. We visualize that these little things that circulate around find receptor sites on cell membranes, that they communicate like keys into a lock. But ultimately, that signal is transmitted by a weak electrical impulse to the interior of the cell. And ultimately, all communication in the body takes place at a physical atomic level rather than a chemical molecular one. And now we understand now, for example, that the EEG waves, brain waves, are not merely the noise of the machinery of the brain, but they are signals being sent to receptor sites on cell walls for these subtle energies. And we know, for example, that the electromagnetic field around the heart is 5,000 times greater than the brain, and it extends out like 12 feet. And we can now show that that changes with your emotions. There's certain specific characteristics when you feel appreciative or warmth or sensitive, and a very jagged thing if you're angry, etc. And you can see that reflected in the EEG of somebody if you touch them. Those factors have a very powerful influence on the heart. And again, it supports the role of emotions in heart disease, etc. And we're now able to measure that where we couldn't before.
It also appears that there are several other mechanisms to explain how stress in general could affect heart disease risk.
Stress can also produce myocardial necrosis, a heart attack, in patients who have no coronary atherosclerosis. Now, the conventional idea everybody was taught when we went to medical school, you had a clot in the vessel and no blood could get through and the myocardium died. But it doesn't work that way. You could have vessels completely occluded with atherosclerosis, and there's enough collateral circulation so that even at autopsy the vessel is closed. The patient has never had any symptoms or electrocardiographic changes because of collateral circulation. The converse is also true. You can have a myocardial infarction and sudden death due to acute stress in young, healthy patients with no atherosclerosis. You can talk to anybody with a heart condition or angina who'll tell you that when they're upset, they have chest pain, etc. And John Hunter, 19th century English physician who elevated surgery to a specialty from a mechanical trade, suffered from angina. And being a keen observer, he said, "My life is in the hands of any rascal who chooses to annoy me," which turned out to be a very accurate prediction because he died 2 weeks later during an argument with a colleague.
I'm taking the Uncle Toby's Oats Cholesterol Challenge for 6 weeks. Because eating Uncle Toby's Oats every day as part of a healthy diet can help lower cholesterol reabsorption. So join me in the Uncle Toby's Oats Cholesterol Challenge. Let's take it on!
The idea that saturated fat and cholesterol cause heart disease has led to a global cholesterol-lowering industry, an industry that generates at least $29 billion each year from medications and specially developed foods that lower cholesterol levels.
Alto el colesterol.
The majority of this relatively new industry is associated with a group of medications known as statins. One statin, Lipitor, generated more than $13 billion in 2006 for the pharmaceutical giant Pfizer. Some authorities have referred to statins as wonder drugs that save thousands of lives each year, and more than 40 million people now take them.
Statins have become one of the most widely prescribed categories of drugs in medical history, and so we know a lot about them.
Dr. Peter Langstjerne has been practicing cardiology since 1985. After 5 years of cardiology at the University of Texas Health Center, he set up a private cardiology practice in Tyler, Texas, where he has worked for the past 21 years. Since 1983, Dr. Langstjerne has been involved with the clinical application of coenzyme Q10. We asked Dr. Langstjerne to explain how statins work and how statins affect coenzyme Q10 levels within the human body.
They are a drug that blocks a biochemical pathway in all cells. Very high up in the pathway, it blocks the production of a compound called mevalonate. That's the precursor for many other compounds. When you block this pathway, you block the ability of cells to biosynthesize cholesterol. Well, there's many branches on this pathway. Think of it as a tree, and you're cutting it off at the trunk. All the branches will be affected. Not only do you lower cholesterol, you lower other compounds. One of those that we know a lot about is this coenzyme Q. So if you take a statin and you decrease cholesterol levels, let's say by 40 or even 50%, which they're capable of doing, you're going to have a 40 or 50% reduction in CoQ10. It's not avoidable, it's the same pathway. So cells that are active 24 hours a day, every day, very active, and that would be heart muscle cells. They don't rest day or night. They use a huge amount of energy, and therefore heart muscle has the highest concentration of CoQ10, by far.
We have the unfortunate effect, therefore, that by giving a statin to try and reduce cholesterol, we may well be blocking one of the most important molecules in the function of heart muscle. So in effect, while statins may be acting, they think, in a good way, we've got very ample evidence that by blocking CoQ10, we are probably raising the risk of heart muscle failure and therefore heart attacks from a different avenue other than arterial blockage.
Most drugs, if they're going to affect you adversely, you can tell it within a day. You swallow the pill and 30 minutes later you throw up or have diarrhea or have a rash, and then you know not to take it again. Statins are insidious because their side effects begin very gradually over a period of months to years.
My experience shows that statin side effects can be very subtle. They can involve other organ systems. They can present themselves months to maybe years after starting the statin, so it's not necessarily within a short time frame. And by that time, usually a patient gets diagnosed as having a whole new disease, and then they're put on a whole new drug.
For the first 11 years of her career, Dr. Catherine Faraday was a medical officer in the US Navy. She now specializes in dermatology and has a private practice in Austin, Texas.
I took Lipitor for 2 years, and I was fairly sick during that whole period of time. After I stopped taking Lipitor, it took me another 2 to 3 years to get to where I started to feel back to normal. Although most of my dramatic symptoms had gone away, I still had memory issues, which I still have to this day, and my energy levels took a long time to come back. I would be saying something to a patient, and then suddenly the next word would not come. In fact, my whole mind would go blank for a couple of seconds. It was like a whiteout. That was frightening. I didn't know what that was, and again I thought, well, maybe it's just stress. I've been working pretty hard, but at the back of my mind I started to fear that maybe I was starting to get early Alzheimer's. I couldn't say the word, but that was my fear. I went home and I stayed home for 3 weeks. I was totally exhausted and depleted, emotionally and physically. And all I could do was stay in bed. It was an effort to get out of bed. I was afraid to get out of bed. I've never been so fearful in my life. In fact, fear was the only emotion I had. I couldn't feel happiness. I couldn't laugh. I couldn't even remember being happy. That was the worst I'd ever felt in my life.
Didn't notice anything for about 6 months, and then started to get a lot of pain, muscle aches and insomnia, and I started to feel really genuinely unwell, as if I had flu. I started to keep a diary about statins because my memory loss was so bad. I thought I ought to write this down because no one's ever going to believe it. So I'll just read you a little bit about what I wrote in my diary at the time. I get lots of depression, light sensitivity, amnesia, unable to write, chest pains, leg pains, incredible fatigue, and some days I can't get my legs out of bed. Symptoms are getting worse, and I need to find out what's going on, as I think I am dying. It goes on and on and on like this, and it's quite scary actually, because I would never remembered any of this. I'm so glad I wrote it down, and I urge other people to write theirs down as well, write down what happened to them.
My friends sort of thought I was putting it on, and it weren't until we were up in Alicante actually with 4 of us having a stroll around Alicante. My walking started to get very tiring, tired legs, and I was having to stop and saying to them, look, you beat a lot, I'll catch up with you sooner or later, because I just couldn't keep up with them. But the memory thing, that's perhaps one of the worst facets of it. I was always sharp, very sharp as a razor. Like I said, I've been in business on and off all my life. I'd remember telephone numbers, you don't have to tell it, but I got it, well, that's it, done. I wouldn't have to think about it. I could go away and think I'd forgotten it and stand there and think, oh yeah, that's it. And I'd have it right. Today I couldn't do that, it would be impossible.
I went to see my doctor, and I kept telling him I found it very difficult at work. I was forgetting lots and lots of things and not completing tasks. And he just said, oh, well, you're getting old. You know, we all do that. It happens to all of us when we get to this age. I was 51.
And it just got to the point where life was pretty near unbearable. Constant pain gets you, feeling not well gets you. Waking up in the morning, not feeling rested and thinking, oh, whoopee, another day. Waking up and thinking, oh, Christ, another day.
There were times when I wondered if I really wanted to go on living. I mourned my health. I felt that I had lost my health. And I felt sorry that I hadn't done things like travel and all those things you think you're going to do. And I felt so sorry that I hadn't done that before I'd lost my health. Now, as I'm trying to be healthy, I'm trying to get enough sleep, I'm trying to manage my stress levels, I'm trying to exercise regularly. My cholesterol continues to be very high. However, I've had several echocardiograms, stress tests, EKGs. Nothing's ever showed any evidence of heart disease. So far I'm doing okay.
When you stop statins, it takes a long while to get over. Some people get over it fairly quickly, but by and large, to feel any real relief takes, I would say, a minimum of a year, because that's how I'm starting to feel better. There's just so many of us now. We're all sharing the same symptoms.
I help moderate a group called Taking Lipitor and Hate It, and I've found out the damage that it's done to people like me and to millions of people around the planet.
The commonest side effect is one that you can't really quantify, which is myalgia. That's basically aching in the muscles. If you measure enzymes in the blood that look at muscle damage, you don't see any abnormality. They're relatively common. And in trials, interestingly, people that were given a dummy drug, so there's no active component, the rates of aching was exactly the same as in the population that had the statin. So, and that can occur in anything up to about 7% of people. If you look at significant muscle damage and complications thereof, the rates, depending upon which agent you use, are about 5 per 10,000 treated for a year, or with one drug which now there have been warnings about at a particular dose, it's about 120 to 160 per 10,000 over a year.
The impression given is that they don't cause or hardly any side effects. I was involved partly in a study in Holland where they asked 50,000 people how many people took statins, what were the side effects. They reckoned there was 30 to 35% of people got significant side effects. Other studies have shown 20%, some studies have shown less. But I personally believe it's in around 20% of people suffer significant adverse events.
I honestly don't believe that doctors do recognize statin side effects, even when they're sitting right in front of them. In the middle of my 2-year illness, I saw my internist for our annual check. After briefly noting that I was seeing several specialists for my dry eye problem, my arrhythmia problem, my colitis problem, and my depression, she then got to the heart of the visit, which was that she was delighted that my cholesterol levels were under control. I find it ironic that neither she nor I ever stopped to question why a relatively young, healthy person had suddenly developed 5 new illnesses in 1 year. And the only new thing in my life was Lipitor.
It's not only possible that GPs aren't reporting adverse effects, it's certain that they aren't. All studies done on reporting of adverse events around the world of drugs have shown that the average reporting varies between 1 to 5%. Most people think it's actually considerably less than that. I would think it's likely that about 1 in 200 adverse events are actually reported. Probably less.
Now we come to an even more serious problem, that is that low cholesterol predisposed to cancer. We have identified at least 11 studies where low cholesterol measured 15, 20, 30, 40 years previously was a risk factor for cancer. One of the most striking findings is made in Japan. Japanese researchers, they gave a small dose of simvastatin to about 40,000 patients and followed them for 6, 7, 8 years. And instead of having a control group, they looked at the cancer frequency in relation to their cholesterol. They measured the frequency of cancer in people with high cholesterol, medium cholesterol, and low cholesterol, all degrees of cholesterol. And they found that those with the lowest cholesterol, those who had achieved the lowest cholesterol value, they had 3 times more cancer cases in that group. There were 3 times more who had died from cancer in that group compared with those who still had normal cholesterol.
And we don't have good follow-up studies. In other words, let's say that somebody's been on statin for 5 years and they develop cancer. Who's to know that? Who's to say, well, you know, we better start looking at, there's no follow-up of that nature.
Clinical trials involving statins have shown that statin benefits vary depending on what is medically known as primary and secondary prevention.
We've had this thing in clinical studies called primary and secondary prevention. Primary prevention means people who have not, say, had a heart attack or a stroke or diagnosed heart disease or something like angina. There are secondary prevention means people who have had a stroke or a heart attack or diagnosed angina. Clinical trials have generally in the past been secondary prevention or high-risk patients, really, I suppose you'd call them, and primary prevention and low risk. So that's really the difference.
Dr. Malcolm Kendrick is a general practitioner who has been researching and challenging the diet-heart hypothesis for decades.
So what I'm really talking about is the development of the atherosclerotic plaque.
He has also worked with the European Society of Cardiology. We asked Dr. Kendrick how much life extension a person could expect to achieve from taking a statin.
You're asking a question of life extension, which is good, because most people say lives saved or prevention. These terms are relatively meaningless. What people want to know is, if I took a statin for 20, 30 years, which is what people are being told, or 40 years or however long you think you're going to live for, how much longer could I expect to live? Which is what people want to know. But what we do know is in primary prevention, there is no life extension. There's no increase in life expectancy. Ergo, you won't live one day longer.
For primary prevention, it turns out that there is no reduction in mortality. There is no reduction in the rate at which people have serious health events. There is a reduction in the rate at which people have heart attacks, but the reduction in heart attacks is compensated for by other serious illnesses. And the net effect is that you haven't improved people's health.
You might change what's written on the death certificate, but you won't change the date. So primary prevention, no increase in life expectancy at all.
Professor Korzik-Ray is a clinical cardiologist and professor of cardiovascular disease prevention.
In what we know from all the trial data that we've got, bearing in mind that some of the studies have followed people up for about 15 years now, but we don't have long-term follow-up data for many of our interventions. But if you look in a primary prevention population over 5 years, the extension in life over that short period of time is very modest.
Professor Ray was the lead author of a study published in the Archives of Internal Medicine in 2010 that investigated the effectiveness of statins. The conclusion of this study was that statins do not extend life expectancy when used for primary prevention. This is highly significant because primary prevention accounts for around 75% of all the people who take a statin. So what about the use of statins for people who already have a diagnosed heart problem?
In the secondary prevention population, you're going to gain many more years in the short term. We know that it will prolong life by a couple of years, even over about 5 years, 5 to 10 years or so, because their risk of having an event in that time period is much, much higher because they've already demonstrated they have a tendency to have these events.
At the end of the study, say there were 50 more people alive on the statin arm than the placebo arm. Yes, there may have been. However, if you extend those two lines, how long does it take before those 50 people are now dead? And the answer is a very short amount of time. I've looked at this with statisticians working in the MRC and using a technique called restricted mean survival time, which does virtually the same thing. And what you find is in the secondary prevention studies, the two that are most quoted, the 4S study and HBS heart protection study, that if you took a statin for 5 years, that was the length of the trial themselves. You took a statin for 5 years, you could expect on average to live for 15 days longer. That's it, total.
Yes, I think you can say that statins reduce the risk or the likelihood of recurrent heart attacks in patients with a history of a heart attack or a history of severe coronary disease or surgical intervention for that. But that's a specific indication. There is absolutely no evidence that it has any role in primary prevention given to healthy people or even people at increased risk for heart disease because they have diabetes, that it has any protective effect.
If the benefits of statins have been exaggerated and cholesterol is not the risk factor we have been led to believe, why have so many doctors bought into the diet heart hypothesis? And how did we get into a situation whereby millions of people are being prescribed medications that could be doing more harm than good?
All right, so what's the truth here? Joining me now is Dr. John Abramson. He is on the clinical faculty at Harvard Medical School.
For more than 20 years, Dr. Abramson practiced family medicine. However, through his independent research, he began to notice an alarming trend within medicine. Dr. Abramson noticed that the scientific evidence was becoming increasingly influenced by commercial interests.
Yes, there's been a radical change in the way medical science is conducted. It coincided with President Reagan coming into office in 1980 in the United States. And he came in with a mandate to downsize government. One of the first things that got downsized was our National Institutes of Health, so that publicly funded research decreased considerably. And researchers who expected to fill out a grant for research in the public's interest suddenly weren't getting funded. And the only source of funding became the commercial interests, primarily the drug companies. When science is commercially funded, the odds are about 5 times greater, surprise, that the science will support the funder's product. So you have 5 times better odds of getting the result you want if you pay for the science.
We are told many, many facts throughout many, many years. And we are beginning to see now that a lot of the facts that we are given are actually somewhat manipulated by the pharmaceutical companies or by other vested interests, such as the food industry, to perhaps give us a flavour or an idea of the benefits of a treatment or a drug that aren't necessarily accurate.
Drug companies not only control the details of how the studies were set up, the protocols, and how the studies were conducted, but they own the research. And this is critically important. The research is done, the drug company compiles the data and processes the data. Peer reviewers read it and say whether it makes sense and the conclusions are justified by the data and so forth. But the real data is not available to the editors of the journal or the peer reviewers. They have to trust that that manuscript is a reasonable summary of the study that was conducted. And often that's not true. We're not talking about some minor details that are spun one way or another. We're talking about major infractions of major violations of scientific standards that are commonplace, and that's what doctors are not understanding.
It's a very hierarchical world, medicine. International opinion leaders say it, the national opinion leaders agree, and as it goes down, no one's going to stand up and go, well, I don't believe that. Who are you to say that? So unfortunately, we do have a hierarchical system of people who will generally just go along with what they're told.
If we have a quick look back over the history of some common names and common drugs, we can see that doctors frequently prescribe and then have to turn around and go, sorry, I prescribed on the best interest, in your best interests and on the best advice I had, but I was wrong. Thalidomide, a drug used for anti-nausea, even though it was an anti-cancer drug in its development, but given to women in pregnancy, unfortunately causing deformities in their babies. Vioxx, a famous painkiller.
With Vioxx, a conservative estimate is that 40,000 Americans died of Vioxx, from taking Vioxx. That is close to the number of Americans that died in the Vietnam War, 55,000.
Another concern relates to the actual definition of high cholesterol. Just a few years ago, a total cholesterol level above 250 was considered high. But this threshold has now been lowered to 200. These guidelines originated from an expert panel of the National Heart, Lung and Blood Institute in America and were adopted by several other countries. The lowering of the threshold, effectively changing the definition of high cholesterol, meant that millions more people became eligible for statin medications. This raised controversy because 8 out of the 9 experts on the panel had financial ties to the pharmaceutical companies that make statins. Although the guidelines were decided by a small number of doctors, they are followed by hundreds of thousands of doctors worldwide.
If they don't follow those and a heart attack happens, and heart attacks happen, those guidelines can be presented in court in a malpractice suit.
A doctor isn't necessarily the one who makes the decisions about the success or harm of a drug, but they prescribe it on the advice that they're given with the absolute best interests of the patient at heart.
And ordinary doctors ought to be brought in as stakeholders in these panels to decide what the evidence really shows. And having experts who have financial ties with drug companies is just like having judges that are getting paid by one of the litigants in a court battle to sit on the bench.
We have been told year by year that we should lower cholesterol even more and more and more. And where is the evidence? I haven't seen any evidence for that argument. The great problem is that these recommendations are written by people paid by the drug industry. How can anybody believe in such recommendations?
60-odd years have passed. And while the science was working, trying to prove the hypothesis, a big and very powerful and very wealthy political and commercial machine has grown on this hypothesis, based on this hypothesis. And this political and commercial machine doesn't want the hypothesis to die.
The level of propaganda and misinformation and even fraud in drug company funded trials on statins is staggering.
This is World News with Charles Gibson.
The widely used drugs called statins, taken to lower cholesterol, could soon become much more popular.
These are the biggest reductions we've seen in heart attacks and strokes, and thus gives us the evidence we need to expand statin treatment to these new patients. People walking around not knowing that they have a risk of heart attack, and it could be reduced with statin treatment.
But yeah, let's talk about the Jupiter study. First of all, it was a very large study, and it was actually ended early after 1.9 years per person because it showed that it was saving so many lives, and it's really rare for a study to get stopped like that, especially because it has good events. I've read all the cholesterol medications, and I've never been this impressed.
Very interesting.
It's really, it's pretty scary. I read it twice, and it's like, really? And it was a well-done study.
And in the Jupiter study, what we discovered was that in the statin arm of the study, after 2 years, the total number of cardiovascular deaths was 12. And this is a study of thousands of people. In the placebo arm of the study, the total number of cardiovascular deaths was 12. There was no difference. The only difference they found was actually there was less people in the statin arm who died of cancer, and that caused them to stop the trial. But in no other study on statins has this ever been shown. In fact, in other studies, the rate of cancer has been shown to be higher. So, you know, we have a study that's basically stopped for completely wrong reasons.
If the Jupiter trial was stopped for the wrong reasons, why were the results so enthusiastically reported in the media? For example, a 54% reduction in heart attacks was widely reported. In fact, this 54% was a relative risk reduction, which is technically correct, but extremely misleading. In the placebo group, 0.76% of people suffered a heart attack. In the statin group, it was 0.35%. 0.76 minus 0.35 is 0.41%. Therefore, in real terms, the risk of heart attack was only reduced by 0.41%. However, 0.41 is 54% of 0.76. So although we were led to believe the statin halved the risk of a heart attack, in real terms, it only reduced the risk by less than 1/2 of 1 percentage point. 54% was quoted in the media because of the press release issued by the pharmaceutical company funding the trial. AstraZeneca used relative percentages, and this was simply copied by the world's media. All of the statin trials have used these relative percentages, which give us a distorted view of the benefits associated with statins.
The lead author of that article, the Jupiter study that was published in the New England Journal of Medicine, actually is a co-owner of the patent of the C-reactive protein. That's the measure that's used that is, if people accept Jupiter, would become a universal screening measure. So you have these press releases that are written, and many of the newspapers in the United States not only picked up the story, but actually editorialized about what a breakthrough it was. And really the only media in the United States that got it right was that renowned medical expert, Stephen Colbert, who said the Jupiter trial was a great breakthrough in figuring out how to get people to take drugs who don't need them.
In 2010, an investigation into the Jupiter trial was published in the Archives of Internal Medicine. This investigation found several other problems with the results of this trial and raised concerns about commercial interests.
We went through healthcare reform in the United States. It was passed in 2010. In the year before healthcare reform was passed, the pharmaceutical industry spent $250 million lobbying Congress. And they had, I think, 15 meetings in the White House that were not publicized. Pharma, which is the trade organization for our pharmaceutical industry, got so much of what it wanted in healthcare reform in the United States that it agreed to spend $100 million advertising in support of healthcare reform. It was so happy with the deal that it negotiated. Well, they spent $250 million to get what they wanted for years and years to come. $250 million is less than 1% of their profit for that year. So with the money that can flow into lobbying and now freely into campaign contributions in the United States, the concentration of capital is so great that there's so much more money than they need to get what they want, that there's not a counterbalance representing the public's interest. So instead of having a dynamic tension between the corporate interests and the public interest, we have an imbalance where the corporate interests get far greater sway over our politicians. And I think what we've got is not a democracy of the people, but we've got a democracy of capital, so that the interests of the insurance industry and the interests of the pharmaceutical industry are, come to some sort of dynamic equilibrium based on their capital. But the public's interest is getting just trounced in this. And because there's so much, the information comes through the airwaves, and the advertising and the public relations that goes on to represent the corporate interest drowns out, even in the media that's trying to do a good job, drowns out the public interest, so that it's almost impossible to get a fair, a balanced view of the whole playing field.
The dynamic tension or counterbalance should be provided by the various health organisations. In the UK, the MHRA is the government organisation responsible for overseeing the safety and effectiveness of medications. And doctors in the UK work to guidelines issued by NICE, who are responsible for looking at the clinical evidence and deciding if medications are cost-effective. We wanted to ask these organisations about the evidence supporting the mass prescription of statins, but both the MHRA and NICE declined our invitation for an interview. We invited the UK government's chief advisor on heart disease, Professor Gray, to take part in this film. However, we did not receive a response. The British Heart Foundation supports the diet heart hypothesis and the widespread use of statins. We contacted the British Heart Foundation for an interview, but they also did not respond. We also contacted the pharmaceutical companies Pfizer and AstraZeneca, who also declined to be interviewed.
Millions of people are employed around it. Food industry is making billions on this idea. Pharmaceutical industry is making billions on this idea. Medical industry is making billions on this idea and employing millions of people based on this idea. They can't suddenly all stop and say we were wrong for all these years, because that would mean far too much for them to lose. They have invested far too much into this idea.
Hopefully, when we look back on this era and we see the fraud that went on in misleading physicians about the scientific evidence, we'll see that this stands as organized crime, that the misrepresentation of science to physicians and to the public stands as organized crime of a higher tech nature than robbing banks with machine guns. But there's a lot more money in this, and in fact, many, many more people get hurt.
Pharmaceutical companies are, of course, a business, and their motivation is to increase profits. They are obliged to increase business growth for their shareholders. This creates a great deal of pressure to develop new products. However, medications take a lot of time and money to develop. In order to develop a new medication, between 5,000 and 10,000 compounds may have to be initially screened. Around 250 of these will enter preclinical testing, with 5 going through to clinical trials on people and 1 as an approved medication. This whole process takes around 10 to 12 years. Developing new products is one way to increase profits, but another way is to increase sales of existing products. Pharmaceutical companies can increase the market size for a medication by investing in the education of doctors and the general public.
So by the time a physician is in practice, he's been taught, very dogmatically by the way, that cholesterol is a villain, that cholesterol and saturated fats cause atherosclerosis. And when they get done with their training and they're out there in practice, they don't change those belief systems very easily.
It makes me angry sometimes. And then I think about all the millions of people out there that are being put on statins, perhaps unnecessarily, in the name of prevention. And maybe we're barking up the wrong tree here.
Pharmaceutical companies, like any other business, are always looking for new markets. More recently, by suggesting that children as young as 9 should be screened for high cholesterol. The costs associated with cholesterol medications are not confined to the cost of the drugs themselves and the health cost associated with the adverse effects, but also the lost opportunity to tackle the real causes of heart disease.
What we've done is we've diverted the public's attention, we've diverted physicians' attention by creating these industry-dominated guidelines that cause physicians to pay attention to their patients' cholesterol levels instead of how they're living their lives. The big picture is not only have you not improved people's health as a consequence of taking these pills, but what you've done is you've drained the energy from the healthcare encounters and healthcare efforts away from the things that really will reduce people's risk of heart disease.
Levels of cholesterol change seasonally. They're usually lower in the summer and they're higher in the winter. They change depending on what we're doing, depending on our level of stress, depending on our nutrition, and depending on many, many other factors. The last thing you want to do is to interfere with your blood levels of cholesterol. Your body knows what it's doing. Whatever level of cholesterol you have got at the moment in your bloodstream is the right level for you. Don't mess around with it.